Hi, class. This is Mr. Hart. In this podcast, I just want to kind of finish up the last of the matter unit, and we're just going to be talking about the gas laws. Okay, so we've talked a lot about the different states of matter: solid, liquid, gas, plasma, and some of the transitions that they occur, right, from solid to liquid to gas, etc. But I really want to focus on certain properties of gases because they have some unique characteristics that we don't see in the other states of matter. Okay, so for a long time, scientists have studied these properties because of the unique features they have. And so this really comes back to times, in the early 1600s, 1700s, or even earlier, when inventions like the hot air balloon start coming around. People start to realize that um, gas has more power than they had originally thought. The idea that you could lift something with a heated gas like a hot air balloon was really an incredible feat at the time. And we start to see scientists looking at characteristics to understand what's happening to gases. Okay, why when you heat it up does this make this balloon expand? Okay, so scientists had started looking at what causes gases to change volume, to change pressure, to change temperature, and some of these things. So the things we call the gas laws are discoveries and relations that have been found from these historic findings. Okay, so the first gas law is called Charles' law. Okay, and this little sign right here, this little thing that looks like a fish, means proportional to. So this little equation, I guess you could say, or expression says that the volume V is proportional to the temperature T. Okay? Or in other words, as the volume of a gas increases, then the temperature increases as well. Or if the temperature increases, then the volume is going to increase. Okay, so if we make this one get bigger, we bring the volume up, then the temperature is going to go up. Okay, or if we bring the temperature up, the volume is going to go up. Okay, same same thing. The idea is as long as we have this proportional relation, as one increases, the other is going to increase as well. Okay. Oops. Okay, so this is Charles' law. So this idea that temperature and volume are related in this way. Okay. Then we have Boyle's law. Okay, so Boyle's law, again named after the person who discovered it, Boyle, discovers that the pressure is proportional to the inverse of the volume. Okay, so what that means is as the pressure increases, then the volume decreases, or when the volume decreases, the pressure increases. Okay, so as this one changes and goes up, the volume is going to go down. Okay, so you can think about like crushing a balloon. Okay, if you inflate a balloon and push on it, as you push on it, you increase the pressure, the volume is going to go down. Okay, so that's Boyle's law. And then last of all, we have Edmonton's law, which says that the temperature and the pressure are directly related. So if I increase the temperature, I increase the pressure. If I increase the pressure, I increase the temperature. Okay, and so when we increase one, we increase the other. Okay, so we have these three laws: Charles' law, Boyle's law, and Edmonton's law, and they all give us these different relations. Okay, so in any situation, you can think about, okay, what is fixed or what is not changing, and then what is changing and responding. So, for example, let's say I have a gas that's in a closed container. Okay, that means the volume is going to be the same, right? It's a closed container, it can't get out. So the volume is fixed. So if I increase the temperature in that scenario, then the pressure is going to go up as well. Okay. Or let's say I have a bicycle pump and the temperature is the same. Then as I increase the pressure, the volume is going to go down, or whatever it is. So these three laws are used to give us certain quantities or certain observations based on the scenario. Okay. So hopefully that will make more sense as you get a little bit more practice, but that's the idea. We look at what's not changing, we determine which law we're going to use, and then we can find out certain properties from the different laws. Okay, so let's look at an example. Okay, so this problem says that a gas starts at a volume of 3 cubic meters, the pressure is held constant, and its temperature doubles. What is the new volume of the gas? Okay, so in this situation, we look at it and we see, hey, the pressure is held constant. The pressure is fixed. It's not changing. So if we look at the law that doesn't have pressure involved, that's Charles' law. Charles' law does not have pressure, so we're going to be using this one. So then it says that the temperature is going to double. So we look at Charles' law. If the temperature doubles, that means the volume is going to double as well. Okay, so temperature doubles, that means volume is going to double. That means our answer is going to be 6 cubic meters. Okay, simple enough. Okay, so again, you just look at which one's being held constant, look for the law that doesn't have that property, and then you can use that law to make observations. Okay, so try this one on your own. Okay, if you're doing this for participation. Okay, a gas has a pressure of 20 psi. If the volume is fixed and the temperature triples, what is the new pressure of the gas? All right. So again, there's a couple. Let's just go through some applications of the gas laws. Okay, if you think about hot air balloons, right? As you heat up the air, the volume expands, right? The volume increases as the temperature increases. That's Charles' law. If you think about like an exploding pressure tank in the movies, they always have the pressure getting too much, right? Until the tank explodes, whatever it is. But in that case, you have the temperature increasing, right? And so the pressure is increasing. That's Amundsen's law. In hydraulics, if you've ever seen a hydraulic, that's using Boyle's law. Different pressure makes a different volume. If you've ever ridden the rocket at Lagoon, that uses hydraulics as well. As you compress the gas as you're coming down on the ride, it increases the pressure, which helps you brake. That's Boyle's law as well. Okay, engines overheating. That's can cause some damage from volume increases. That's Charles' law. And crushing a balloon we talked about, which is Boyle's law. Okay, so there's lots of applications to these laws that we can see in real life examples. Okay. All right. So one thing we talked about in class is if the pressure increases and the temperature increases, then why do hot air balloons float? So that's a scenario we talked about, and it has to do with because the balloon is not a closed system. Some of the gas escapes, which helps it, I guess, flow around better. The air can move out and in so it can float. Again, we talked about more in class, but you can look that up if you are interested. Okay. Then I did a video of me crushing a can using Charles' law. If you didn't see that, it should be on the site, so you can watch that experiment. Okay. I also did the film capsule in Alka-Seltzer, which I used pressure buildup to shoot off a film canister capsule. We watched this video about the egg and the bottle. We can get the egg to fit into the bottle by using pressure and the laws. Okay. And then we talked about the gas laws lab, and we did that activity in class. So again, if you missed class, then you should make up this activity. And then after that, we started our review for the test. So that is the end of the matter unit. So hopefully this makes sense. Hopefully I've been able to answer any questions you've had. But if you still have questions, feel free to email me. And thank you for watching.